All right, well, welcome to the Jupyter on Chameleon webinar. Today's speaker, Jason Anderson, is Chameleon's DevOps lead, who splits his time between wrangling clouds at work and herding cats at home. Jason joined the Chameleon project almost a year ago, previously working on application development and operations at SoundCloud in Berlin. With an industry background, Jason has only recently been introduced to the world of academic research, which sometimes feels quite a bit different. His interests are around enabling researchers and understanding what problems exist for everybody out there doing this type of work, and hopefully how Chameleon can work to solve those problems. Today's talk, which is about using Jupyter's notebooks as a powerful tool for computer science experimentation, will last about 45 minutes with time for questions at the end. During the presentation, please type general questions into the Q&A box, not in the chat box. Paul Ruth, one of the principal investigators for Chameleon and the networking lead, is joined by Kong Wang and Mauricio Traveres, also members of the Chameleon team, who are on the webinar and will be answering your questions. Thank you and welcome, Jason.
Unmute him. He's muted. Oh,
Thank you.
Right.
Thanks for the introduction. So today we've got a lot of ground to cover actually in just 45 minutes, but the general agenda, which you should see now on your screen, is that we'll be going over the Jupyter Lab user interface, which is what you're looking at right now. We'll go over an example of a real world Jupyter Notebook for those of you who maybe just aren't even familiar with like, what is this? And then I'm going to be doing like a sort of a run through of how you can actually use Jupyter Notebooks within Chameleon, not only to just sort of interact with the Chameleon Cloud Testbed and what that is, but also running an actual live experiment all through the Jupyter interface. If there's time, we can get into some more advanced topics, but I would rather kind of leave a lot of time at the end for questions for Q&A. Because I'm sure there'll be specific things that you would like to talk about. But the end goal would basically just be, if you don't take anything else away, get a little bit acquainted with the Jupyter Lab interface and what a Jupyter Notebook is, if you're not already familiar. If you have an active allocation on Chameleon Cloud already, it would be cool if you could try logging in and following along with the tutorial. But that's not a requirement. I would say if you don't have a Chameleon account and you really want to follow along, we do have a few, I believe, tutorial accounts set up that you can maybe message in the Q&A channel, ask a question to get that. But really, it's not necessary. You can just sort of follow along with me, and I think this will be recorded, and I'm sure we'll release it, and you can follow along afterwards. And we also have this tutorial as a Jupyter Notebook that you can walk through, and in fact, that's what I'll be doing during the webinar. Last but not least, I hope you leave with some inspiration about how you can actually use this tool to sort of experiment, even if you're in the pre-experiment, or like when you're actually running an experiment that you intend to publish. Jupyter can be a really good fit. So we wanted to kick off the webinar series with Jupyter because it's sort of becoming quite a popular commodity tool for academic research. Kind of comes from the data science land. If you've used Wolfram or Mathematica, it actually looks very similar to that. The general idea is it's a computational notebook. So it's a mixture of text and code. And this sort of very simple property allows you to really nicely iterate through an idea, especially when it involves code. And as such, again, it was very popular in data science. It kind of then bled its way into the domain sciences, computational domain sciences. And now it's been being used a lot more for computer science research as well. So before we get any further, I'm going to go over the Jupyter Lab interface first, but I wanted to tell you how do you even get here? Well, if you are a Chameleon Cloud user, you can go to jupyter.chameleoncloud.org, which you can see behind me. And I'll also just sort of show you how this works here. Move my screen a little bit so I can log out. So I'll just log out of here And what you'll see is a page that looks like this. It doesn't have any Chameleon branding yet, but this is what's called the JupyterHub. And you might be familiar with this. I think some academic institutions have these set up as science gateways. It's just basically a way where you don't have to run your own Jupyter server, which normally you used to have to. This is kind of a managed Jupyter server solution that we actually operate for you in Chameleon. And there are some additional cool things about that that I'll get into. But because it's operated by Chameleon, you can actually log in with your Chameleon username and password. And if you have an active allocation, the first time you come here, it'll take a little bit because it's actually creating the server for you on demand. But then you should actually land into your server environment. And this is mine. And as you can see, I'm back where I started. It's pretty good about saving where you were. So going over just to get a lay of the land here a bit, we've got the Jupyter Lab interface. First of all, for those of you who've used Jupyter Notebooks in the past, you might not be familiar with this. This is relatively new. This is kind of the next iteration of the user interface that the Jupyter team has developed. And I think this is kind of what they're going to be developing more in the future. So that's what we opted to give to you. That being said, using the old interface is always an option, but I'm just demoing the new one because I think it's more into the future. So for a general view at the top, you have a menu bar, which is very similar to any sort of rich application that you've used either on the web or on your native machine. And then on the right is your main sort of viewing editing area. It has tab navigation at the top to sort of, if you have multiple files or views open. This top bar inside of this view, which is a notebook, you probably recognize if you've used notebooks before. There's a few simple things. You can save your notebook. They still use the floppy disk as the save icon for some reason. And you can also, we'll be going into how you actually edit a notebook later. But the more important part is, for now, is on the left. You have a pretty nice file browser. And if I click the home thing here to go back to my home directory, this is your home directory. Everybody who logs into the JupyterHub will get their own server with their own home directory. And when your server is destroyed, because we do clean these up from time to time, your home directory should be preserved. So any work that you're doing will stick around in there. Additionally, we drop two things in there for you for Chameleon. The first is this little welcome notebook, which just gives you a little bit of a sense of how you can use Jupyter and if some examples of interfacing with the testbed. But the other thing that we do is you have this notebooks folder, and this comes with a lot of examples, tutorials, and sort of real world notebooks that we've developed for you to get started. And there's only a couple right now, but this is something that we're looking to sort of invest in over time. And these can, I think, will be automatically updated. Like as you log in, could see more stuff. That's the general thing. The other last part is sometimes it's hard to find the logout link, which you might want to do. It's because we're using this JupyterHub thing. You can find the hub item at the top, and that will give you that. Additionally, it will take you to this control panel, which isn't that interesting because you basically just have two options, and one of them takes you back to where you were. Oops. In this case, it opened up a new window. Okay, so quickly, I'm just going to go into a real world Jupyter Notebook to kind of give you a sense of what it is that I'm talking about here. So I just made this little toy example called Time to First Byte. And this is kind of a little made up experiment. And so as I mentioned before, the cool thing about Jupyter is it allows you to mix text and code and really tell a story. And which is useful not only for presenting your research, but also I find just thinking through the problem. And so in this case, I'm constructing an experiment where I'm measuring the time to first byte and defining what that is for you so you know what I'm talking about, which is the amount of time it takes for the first byte of actual content to come back from a server. So this notebook has a few different text, what's called text cells at the top. And these things are just markdown. You can actually double click in here and you can add some text, and then you can run the cell, which is basically, it converts it back into a textual, or sorry, a rich representation. So you can see that. You can also shift return to quickly execute, which is what I usually do and what I'll be continuing to do. But the really interesting part is actually when you're mixing this with some actual code. So here we've got two code blocks. The first part, I'm kind of setting up some parameters of this experiment, which is I'm going to take 10 samples from these two different hosts, www.uchicago.edu and www.anl.gov. And we're just going to compare how long they take to respond. So I run this cell to sort of execute it, and all it's doing is saving values into those variables. And now we have another cell here, and this is kind of the crucial part, is that this cell has the exact same scope as the rest of the cells. So any variable that I declare up here earlier, I can use down here. And it's important to note that Jupyter actually has a built-in assumption that you're executing from the top down. So anything that you declare above, you can use below, but not necessarily vice versa. So you should really set up anything that you need further down at the top of the file. It's kind of like it's just reading the file from top to bottom. Anyway, so I've got those two hosts in there, and now I have this little sort of Python code that is actually under the hood just making a curl request. And I'm going to run that. And it's making 10 requests to each host, and I just have a little progress bar there just for niceness. And it's storing them in this little hash thing here. Okay, and now later, another really excellent part of Jupyter is that it has really good built-in support for visualizations. And in fact, this is mostly what people use Jupyter for, is visualizing data. And there's several well-known Python libraries that we've included into the notebook servers by default, but you're free to install new ones as you wish. And I'm going to use two of them, matplotlib and NumPy. And I'll use the data, to render a histogram of the response times for those two hosts. Now, just to prove to you that this actually sort of works to edit and adjust my experiment, I'm going to change this to actually measure 3 hosts now, and I'm going to be very unfairly comparing them to google.com. And yes, we'll see, in fact, that google.com returns significantly faster than the other two sites. So that's just a little example of what a Jupyter Notebook is and how you can maybe use it. As you can see at the bottom here, it's actually quite nice for generating visuals that you can use from your experiment, but also there's nothing hidden here. All of my experiment has been taking place right here. You can see all of the code, you can see all the parameters, and that's a pretty cool thing as well. It makes it so that you can share these artifacts with other people, whether that is your people of your research team, your advisor, your PI, or I think it's becoming more common to submit Jupyter Notebooks as part of an academic paper or a poster as sort of a side artifact of allowing people to reproduce your experiment. So that is kind of a general overview. And what I wanted to do now is sort of go over some of the special cool stuff that you can do by virtue of the Jupyter environment being integrated with the Chameleon testbed. So if you're not familiar with the Chameleon Cloud testbed, you should first go to chameleoncloud.org and read more about it. As you can see, it's a configurable experimental environment for large-scale cloud research. But you can really think about it as kind of a very specialized for science AWS. It's something where you can make advanced reservations, or basically you get on demand. You can get not on demand. You can get bare metal nodes provisioned for you remotely on the cloud that you can then log into and perform experimentation on. We have a large amount of nodes available, some highly specialized ones that you will have to make advanced reservations for because they're so in demand, such as GPUs and FPGA nodes. However, we have a sort of large-ish array of commodity hardware that you can also reserve. And we're going to go through actually reserving one of those right now. And you'll see that for all intents and purposes, it can be treated as an on-demand sort of instance being spun up. And to go over that, though, I'm going to actually use a tutorial that we built. And it's in the notebooks tutorials, bare metal, beginner, and intro to bare metal. So Chameleon is unique in that it's not like AWS in the sense that we provision exclusively with bare metal machines, which means you get the entire machine. You're not in a virtualized VM environment. You actually get raw access to the bare metal. And this is pretty cool, and this is kind of what you can do with the testbed. But first, we're going to go over like how can you actually do that inside of within the context of Jupyter. So this tutorial walks you through that, and what we're going to do basically is make sure that we can communicate with the Chameleon testbed, which you should be able to do by virtue of being logged in. We're going to make a reservation for one node and a public IP address. And then we're going to provision that node with an instance and check that we can SSH to it. So this is a live demo, so let's just see how we go. But I'm just going to follow along here. I think the notebook is set up that you shouldn't actually need to change anything. It should just be like follow along. But I'm setting a few variables up here to talk about what type of node I want. And there's a link here that you can see all the types that we have. And then also the rest of the things are kind of just setting up like what's the name of the lease, what's the name of the instance. And this is mostly to make sure that you don't run into any conflicts of naming or just so things make sense when you see them in the interface later, which I'll also show you. So step one is just make sure that you can actually authenticate to the testbed, which, haha, I can. You may need to enter your specific Chameleon project here. And if you only have one project that's active, it should automatically just pick it for you and you should be good. But the main thing is that we actually have the ability to communicate with the Chameleon testbed from Jupyter. And so what can we actually do with this? Well, we can make a reservation for a bare metal node and for an IP address. And that's what the next step is. We're using a system that we have in Chameleon called Blazor, which is responsible for reserving resources. And in this case, tutorial has crafted a very special invocation that will contact the Blazor reservation service, and it will request a lease for one day for me to be able to log in and use a bare metal node. And it just sort of takes a little bit for it to go. We should see it, print out a big summary of the lease here. So there it goes. Okay, so now the lease is in the pending status. It could take a little bit for it to actually make sure that the node is reserved and also that there's space in the IP pool for me. So, but I can have there's a little helper here. I can run to sort of wait. I just did, and it's actually already started. So we're doing well. And step 3. Now we get to the cool part. We're actually going to provision a bare metal instance. But the first thing we need to do is make sure that we have a key pair created. And this is important because all Chameleon images require SSH key-based authentication for security. The cool part is your Jupyter server already has an SSH key generated for you. So all that you really need to do is create, basically upload it to Chameleon to tell it that like, here is a public key that you can use to authenticate. And I've already done this, so I'm not going to run this step. But the next step, that's what it's for. But now what we do is actually create the server. So I'm just going to create a sort of stock, provision the server with one of our CentOS 7 images. I'm associating it with my key pair. And we also provided a little helper script to sort of fill in some of the more important default values for you. And I'm just going to run this, cross my fingers. And it was going to go about requesting that a provision event happen for the node that I reserved in the previous step. All right, so it's starting. And now I'm going to actually just, I'm going to let it, another wait loop, let it wait and wait for the server to start. So this step will take a little bit, so we might jump back and forth. One other thing to point out, it's a little bit hard to know when your notebook is actually doing something. So in the top right, though, you'll see there's this little circle. When it's gray, it says kernel is busy, and it means it's actually working on stuff. Additionally, you should see in your browser the little tab, favicon. It'll be a little hourglass that sort of indicates that it's working on something in the current tab. So just to prove to you that this is actually doing what I say it is, we can click in to actually view the bare metal graphical user interface for Chameleon. And I see that my tutorial instance is actually building right now. So within the Jupyter Notebook environment, just by virtue of you having logged in with your Chameleon credentials, you can actually interact with the testbed without leaving Jupyter whatsoever. I'm just sort of coming into this interface, which maybe you haven't ever seen before, but this is kind of the general view of all of your servers that are running at a time on Chameleon. So as you can see, my server is starting. It takes about 10 minutes for it to start, and but I have a backup prepared, which is this demo backup thing here. And we might just start using that. So go back to my other thing. We're going to pause this for a bit and move on. So the more interesting thing than just poking Chameleon to say, like, I want a server, is to actually use that for something. And part of this talk is about writing an experiment using Chameleon resources, but also just writing an experiment in general with Jupyter and what that can look like. So again, I have a little bit of a toy example I put together, and it's a power experiment. So I'm just going to be measuring how much power a bare metal node draws when I stress various percentage of its CPU cores. The hypothesis being that if I stress more, then more power will be used. So the interesting thing about this is I've actually broken my experiment up into a few different steps. And the other interesting thing is that I didn't really go over this before, but you notice that we weren't actually programming in Python in the last notebook. We were actually programming in Bash. And I think maybe a lot of people using Jupyter, you associate it only with the Python programming language, but that's actually not really the case. You can use various different, what Jupyter calls kernels, to interpret code. Python just happens to be the most common one, and it's the default. But we've also installed a Bash kernel into the Chameleon Jupyter environment because I think we find that it's much easier to actually interact both with the testbed and with the setting up the experiment when you're just using a regular shell like you would normally use. And that being said, you can actually just use it almost exactly like it is a normal shell. So I have over here, for this power experiment, a setup script, which I need because I'm actually just using a stock Chameleon image. I have a note here that it is possible actually in Chameleon to save a snapshot of an image. So if you provision a node, you can do some special things, install some additional software, and you can snapshot that entire disk image for later use, and then you don't have to do this. But for the purposes of this, I'm just showing you that you can actually run sort of arbitrary scripts. And in this case, yeah, I'm going to run a setup script on my remote instance, which I'm reaching over its public IP address. And I'll show you how to set that up when we go back and hopefully our server is launched. So the only purpose of the setup script is to install any sort of dependencies that I need for my experiment. My experiment is going to use a tool called stressng. Stressing, I'm not sure how you say it, but it's basically a tool that just really thrashes CPU as hard as it can. And we're going to use that and a combination of another tool to actually measure the output of power and energy from that extracted from the kernel. So I also put my experiment in a script. And this is nice because then I can sort of structure it in a few different steps. And I also have control over the different parameters and also where I'm going to save the output. So my script is basically, I have this sort of run task function, where I give it a task to run, which in this case is run a stress test. And I tell it that I want you to sort of stop after so long, and I also want to use this eTrace tool to profile the power and energy usage. So what I'm basically have set up here is some way to test running some program and measuring the power and energy consumption for a given time. And I do it 3 times. First, I use only 25% of the cores, then I use half the cores, and then I use all the cores. I always output my files on on my actual bare metal node. Like, remember, this is actually running not on my computer. It's not running on Jupyter. This is actually running on the bare metal node that I've provisioned from Chameleon. And at the end, I sort of zip up all the results into a tarball because that will be useful, and we'll see why. On the Jupyter side of things, so it's definitely possible to run all of this through Jupyter. In my case, though, I find it much more convenient to manage the script as like a separate file, and then I just upload it to my server every time before I'm about to start my experiment. That way, if I make a change to my script, it's always on the server, and I don't need to really think about, is it up to date? So I always copy it. Then I just tell it to run with some parameters that I can define here. So I believe this means I run each test for 10 seconds. I sample every half a second, and I think I wait 5 seconds in between each little run. And we'll just run this. And now we should see some output. StressNG says it's dispatching hogs, which is one of the best things I've ever seen a program output, actually. And so it's running now. It did my first run looking at only 12 CPUs. Then it looked at 24. And soon it will have finished a run stressing the entire machine. Just wait for that to finish. And again, once it's done, it's actually going to package up all the results, but those results are still on the remote server. So what I did at the end then is I download the results from the remote server, and then I extract them into my Jupyter Notebook environment. And all that's done now. And if I see here on my left-hand side of the screen in this out folder, it says it's updated seconds ago. And that's because I actually did get some results. And here are the results that were generated. I can see my power consumption, energy consumption. All right. So that's all well and good. That's an example of how you can actually run a somewhat complicated experiment in a sort of very reproducible way. I can run this as many runs as I want. I can iterate on the run script and sort of make a few changes and then rerun and have the results collected. But the other part that's interesting then is to analyze this data within Jupyter. And I find this is kind of the most useful pattern, especially if your data set is relatively small. There are some interesting challenges if you have really big data sets that you should talk to us about. But if you're just sort of running some bits where you're analyzing some performance results, it's actually totally feasible to do this all within Jupyter. So I have a separate notebook for analysis. And this is kind of a technical constraint based on the fact that you can't have one Jupyter Notebook support 2 languages currently. So I was running the experiment in Bash because that was the most practical solution. But I'm going to analyze it in Python because Python has way better libraries for, or it just has libraries in general for sort of chunking through data and displaying it. So here I'm using a few sort of standard libraries like matplotlib and pandas to get all of my data. And what I'm going to do then is I read all of the files in my output directory. And then I sort of, each file has a little suffix where I have sort of tagged which run it was. So like, is it running at, was it the 25% CPU case or the 50% case or the 100% case? And it takes a bit of time, admittedly, to sort of understand some of these libraries. And I sort of had to jog my memory when I was preparing this demo. But the nice part is once you have it, it's documented and it's not that difficult to tweak. But what I have here, I'm going to be iterating over my runs, and I designed my experiment actually to support like rerunning the test over and over again, and then computing like a median of the values. And so my example is a little bit complicated because I'm doing that. But really, all it's doing is parsing those files as it's reading them as a CSV, even though they're space separated, reading the data, and then it's plotting them. And I'll just run this, and didn't take any time at all. And it's outputted these two nice graphs for me showing the median power consumption and median energy consumption as measured by eTrace for my 3 different test cases for it's kind of interesting. You can see that at the 25% case, it's at 140 watts, jumps all the way up almost to 190 for the 50%, but there actually isn't a huge gap to go from 50 to 100, which is kind of interesting finding that I didn't personally anticipate at first. So I hope that's given you a little bit of insight into what you can actually do in terms of setting up a real experiment. But to switch gears just a slight bit, we need to go back and let's just see if the other notebook, if it's ready for us to finish up, so I can walk you through the rest of that. So while I was showing you that, again, we were sort of waiting for our instance to spawn. And if I go back, I can actually see that, yes, it is active. Very cool. So remember, we were provisioning a bare metal instance on Chameleon. And by default, when you do this, Chameleon does not assign a public IP address to it. This is partly for security, partly for sanity. We don't have a whole lot of public IP addresses, which is why you actually are encouraged to reserve them. But instead, when you spin up an instance, you just get a private IP address. However, in order to actually access it via SSH, like I was doing to actually run my experiment, you do need a public IP address. So how do you solve this impossible conundrum? Well, we actually did reserve a floating IP address. And what you can do, this next step, you can actually figure out which IP address was reserved and then tell Chameleon to attach it to your server. And so you can also see we're using most of this stuff and most of these tutorials that use Bash use this OpenStack CLI. And this is because Chameleon is actually built on OpenStack technology, which is sort of an open source cloud provider technology. And so a lot of the stuff that you see, you're actually using OpenStack commands. You might wonder what that is, but that's just how you're talking to Chameleon. It's just because it's using OpenStack as the underlying technology. So anyway, I'm going to just run this cell to attach the floating IP to my instance, which it says it has done. And then I'm just gonna, it sometimes takes a little bit for the routing rules to propagate, so I'm gonna wait for SSH, but it's already running, which is great. And finally, I'll test that I can actually connect to my instance. And bam, I can. And I can actually, the other cool thing to mention here is that Jupyter, the Jupyter Lab interface rather, you can be in a notebook, but you can also open up this very useful view. And I need to actually see which IP address, this one. So on the left in the file menu, you can do new, and this is how you create new files, obviously. You can create new notebooks, but there's also 2 very confusingly similar options, one called console and one called terminal. Console is actually a read eval print loop console for Python, or I mean for Bash, it's basically the equivalent of the next one, which is terminal. But console is useful if you actually just want like an interactive programming tool for a particular language. But what we're going to look at is terminal. And this actually gives you a pretty nice, actually, sort of terminal view into your Jupyter server instance. And keep in mind, this is like, the way that we actually do this at Chameleon is you're running inside of a container. So you're namespaced to yourself, and you can actually install other software into this container as well. But I just wanted to show you mainly that I can actually SSH to that node that I just assigned a public IP to, and I'm in there. And I can sort of move around, and I can do whatever I would normally do with my instance, all within this Jupyter interface, which I find pretty convenient. And this is all made possible because when we started the instance, we made sure to tell Chameleon that it needs to allow our Jupyter server's SSH key for login. So that's kind of the general sort of landscape of stuff I wanted to go over, actually. And I'm pretty happy that the demo didn't block up, as they are often wont to do. So I wanted to actually turn it over now. I haven't been looking at the Q&A, but I wanted to maybe answer some questions that you might have about this, if that's okay. Okay, so Anirban asks, what is the mount point? This is a good question. I need to actually just all set up. Yeah, so this my mounting point thing, the Chameleon testbed comes with an object store built in, which is useful for storing large data sets or certain experiment artifacts that you might need. The cloud paradigm being that you don't necessarily couple all of your experimental data in with your disk image, rather that, because that means disk images bloat to gigantic sizes. Rather, you store your experimental data ideally somewhere else in the cloud that you have access to. So Chameleon has an object store, and there's we have a section in our documentation, as with most things about this, called Swift. And this works very similarly to AWS S3, actually. It's almost a drop-in technology replacement for that. The mounting point that you see in your instance is something that we add for you. And what this is a fuse mount into, I believe it's into all of the sort of containers, or all of like the sort of sections of the object store that are scoped to you. So all of the places that you have access to. So this can be useful if you want to easily move data in or out of the object store. But I should stress that it's not a remote block storage system. So it's not going to work the same way that you might expect a regular POSIX file system to work. In particular, like appending doesn't work the same way you think, because you're actually not dealing with block storage, you're dealing with object storage. And this is also addressed in the documentation. But it can be a useful thing to put artifacts, especially if you don't want to store things in your disk image. And it's just there for your convenience. And sort of sitting around for some other questions. Any restrictions to bringing files in from the outside? I don't believe that there is. I mean, there might be. So I do know that so that our JupyterHub environment runs inside of infrastructure at University of Chicago in Argonne. And for security, we are behind various intrusion detection systems. That being said, if you're like installing stuff or need external dependencies, it's pretty much available to you. So you can install new packages with apt-get. You can pull in stuff from GitHub. You can pull in stuff from other remote sources. But with the caveat that, you know, always responsibly vet the sources that you're pulling in. But yeah, there's not actually any material restrictions on what you're allowed to pull in. Part of the reason that we designed this way, using a container approach, was to sort of let you have a lot of control over your environment. So in fact, like, you know, you have sudo access, so you actually are able to do a lot of things inside of this container environment. I'm just wondering if I sort of went a little bit fast. For any of the my fellow Chameleon members, is there anything that you think I should go over a bit more? I'm happy to do that as well.
So Jason, like I don't really know. Well, there's another question. Maybe you want to answer that one.
Oh yeah. The best way to move large data sets to Chameleon Jupyter for deep learning. Okay, so yeah, for very large data sets, I think actually the managed JupyterHub is not going to be the right approach, mostly because it's still technically a relatively shared environment with other users. But I think the best thing that you could do is actually provision your own Jupyter Notebook server on bare metal for this. We don't yet have an appliance for this, but this is something that I think we've recognized there's a need to do. And by the way, when I say appliances, what I mean is part of Chameleon is about giving you pre-configured software packages and pre-configured images and what's called orchestration templates, which is basically like allowing you to spin up a cluster of a certain thing with like an NFS cluster or a Hadoop cluster or something. And we don't have one of these for Jupyter that I know of. So we do have something for TensorFlow, but we don't have anything for Jupyter specifically. Actually, no, this has a Jupyter Notebook built in. So you could actually use one of these TensorFlow appliances if you're interested in TensorFlow for deep learning. You could provision that on the testbed. I believe it even supports, the parallelization aspects of TensorFlow. And as far as moving the large data sets, you first need to get it into Chameleon. And once you do that, I think then it becomes much easier to run your experiment. So your step would be first get your large data sets into the Chameleon testbed, and you can upload them from your academic network or from your laptop or however you do it. There's instructions in our documentation. If you look for object store, you'll find information about how to do that. 200 gigabytes is pretty big, but I'm pretty sure that our object store supports large files, and it does so by kind of sharding them into smaller bits. Should be possible, and I would definitely want to enable this. So if you have problems, please email us, and we'll see what we can do. But that would be your first step, getting it into our object store, and then from there, in your when you're using the TensorFlow or whatever appliance, you would basically pull it in, copy it, or either through that mount that we talked about, or just by making a one-time call to fetch it into your environment. It is on our we're interested in providing a real remote block storage device solution. I don't know if this is really something that helps a whole lot with deep learning, but it's something that we're interested in doing so that you don't have some of the limitations of the object store, which is it's hard to sort of write to and seek at various points. But another question was any stacks with the Jupyter Notebook? Well, so yeah, I'd actually embarrassingly, I didn't realize that the TensorFlow one actually comes with one. I haven't tested this myself. This is not a Chameleon supported one, which all Chameleon supported means is that Chameleon team members wrote it, and we're responsible for fixing bugs. So this one's not Chameleon supported, which is why I didn't really know that much about it. But it comes with a Jupyter Notebook. There might be others that do, but just don't say. I'm not sure. But I do think that, as I was saying before I got sidetracked, there is a use case for just having a Jupyter Notebook image. And I think that's something that we should provide to you. And so I'd say that there isn't another example of the stack, but installing a Jupyter Notebook is relatively easy to do. But if you're really doing if you just need to sort of start experimenting and playing around, that's kind of what the JupyterHub environment is for. So we kind of wanted to give that as a getting started, especially for students or for people who are doing experimentation that is mostly heavy on the node side and less on the like crunching data side, it's a really good fit for that. And yeah, as Kaivan mentioned, if you really need to deal with some heavy crunching stuff, then it's probably best to do your analysis on the bare metal node itself via one of these appliances. And yeah, in regards to the tutorials as well, like you might notice that there's, we do have other tutorials that are interesting to do. But as I said, it's kind of like we're sort of starting to build this stuff out. And I am going to actually put this CPU stress little thing into the examples so that you can actually see the example of what I was talking about and how you can use it on a server that you provision yourself. We do have one other advanced tutorial, which is more for if you're doing advanced OpenFlow network experiments with SDN. This actually walks you through the process of setting up a what we call a BYOC, bring your own controller, OpenFlow controller network on Chameleon. So it's kind of completely the opposite type of experiment that I was just showing, but also possible to do with Jupyter as well. Any other questions? And I should note, so there's a ton of information on the Chameleon documentation. And I really recommend if you are trying to do something specific with the testbed that you do invest a bit of time to read what's possible. We make a great effort to keep this up to date whenever we release new features or we make something possible that wasn't possible before. And this is kind of like the living document of what's possible on the testbed. And there's a lot of information about the object store, like I mentioned before, about using FPGAs on Chameleon and what's involved there. The complex appliances goes over that, like for example, that TensorFlow image, I believe is a complex appliance, as well as just sort of the basics of how do you get around Chameleon, what are the interfaces like, and what does it mean to make a reservation, and what is bare metal. All these terms are defined for you.
So Jason, the other thing that you might, I don't know, touch on or something is that there's several people that we're trying to get their accounts working, right?
Mm-hmm.
So those people should like stick around or send us open tickets or something. I don't know. You can address that. Like there's some things where the Jupyter Notebook got stuck in spawning and a couple accounts that don't seem to be, I can't add them to projects for some reason.
Okay. Yeah, so everybody can stick around. I still have, I definitely have time after this to help work through various issues. I will say that we haven't actually done a stress test of this magnitude of the shared server environment with so many people logging on at the same time. So it's possible that we hit some fun things that we haven't seen before. But yeah, we'll work to make sure everybody's set up.
There's other people that have tried it or are writing me in other ways that are saying that it's working fine and it's great and it's very cool. So I don't know. I think that whatever the problems are, they're individual problems.
Sounds good.
All right. Well, thank you, Jason, for presenting this talk today. Like you just said, if you want to stick around and you can directly chat him with any specific questions that you have. And then other than that, we just really appreciate your time. And please make sure to join us in 2 weeks for our next webinar, Introduction to Chameleon, which is on June 4th. And you can register for that by visiting the Chameleon website. There's a webinar tab there. So thank you all and have a wonderful rest of the day.
Thank you.
Hi.
Hello?
Hi, Jason. Is this Jason?
Yep.
So thank you for the wonderful talk which you just gave. I'm just trying to get my account set up here. So within the Chameleon cloud.org, not the Jupyter interface, but I do see that I'm added into the project, the tutorial project. But when I go to jupyterlab.chameleoncloud.org, I log in successfully, but then it gives me launch server. So I say launch server, it just comes back to the same thing which says launch server.
Interesting. Okay. Just sort of trying to see if I can find your server over here. Which user account are you logged into?
Sorry, what was that again?
What is your name of your username?
It's Alifia. That's
okay.
Yeah.
Yep.
I'll add, Jason, that there's at least one other person that's having, or maybe I think 2 people that are having the exact same problem. So it's just a Jupyter thing, I think.
Yes. Yeah, I do actually see the error as well. I don't know if you've already tried this, but you could try force logging out of the Jupyter instance or the Jupyter Hub again.
I tried that several times, actually.
Tried that at okay.
Yeah, I tried that several times. I even logged out of Chameleon just to make sure, there was any state.
Yep.
But that didn't seem to help. But I can do it again if you want me to. I'll do that right now.
Yeah, because I guess it's there's so many different layers of login. You actually need to go to I guess you can probably see the logout link. But so if you've already tried that, I mean, I do see that it's having some problem authenticating your account. I'm not totally sure if it's to do with the tutorial project somehow or not. We need to look at that.
Okay. That's okay if we can't resolve it right now. It's just, do you want me to open a ticket? Should I send you an email just so that we can, I would, this interface looks great. So I do want to try it at some point.
Of course. Yeah, I would say definitely send us a ticket. And I'm gonna look into this right now though to see if I can resolve it for you. But if you have a ticket open, then I can just get back to you then when I've fixed it.
Right. How do I create a ticket? Is this through a Chameleon cloud interface?
Yes. If you go to chameleoncloud.org and if you're logged in at the top right, you should see your name. You can click on it. Maybe I should just share my screen again.
So help desk, is that what I do?
Exactly.
Okay. Open a ticket. I see it now. Okay.
Yep.
Perfect. I'm going to do that right now. And you have contact, so I'll mention your name just so that.
Yep. That sounds good.
Thank you so much. I deeply appreciate it.
Yeah.
And maybe we're opening up a bunch of problems for ourselves, but like everyone else that has similar problems, maybe do the same thing, and whoever answers the question, we'll get back to you as soon as we can.
Yeah, I mean, I do suspect, is it the case that everybody who's had problems, are you a member of the tutorial project, or are there some people who are independently are having issues? Do you know, Paul? Or
I think that so some of the people I added actually to the tutorial project this morning, because I got the first list this morning and I added them. So they should have been in lockdown, but they had during the tutorial. So it could be that they never got synced, or like all the authentication layers got triggered and something went wrong. I don't know. But
yeah, sometimes these things take a bit of time just to get sorted out.
So it could be that we just need to force the sync again, but I don't know how to do that. But a couple of them I know for sure, especially, and Alifia is for sure I added this morning. So that one should have been working, but I don't know.
Yep.
Yeah, can I, Jason, since I have you on the line, can I ask you a couple of questions? Do you have anything on, so the JupyterHub, there is a server which runs. Do each of the bare metal nodes have a piece of code that enables you to run what's in the cells? Like,
yeah, so when you're actually running stuff in the cells, you're running it, you're not running it on your bare metal server precisely. I think of it more like you're kind of the brain of the experiment, and you're kind of poking other things that are doing the work. If you're actually using, so like in my case, I uploaded my experiment script and then I told the server to run it via Jupyter. But otherwise, if you're executing the cells, those are taking place within this kind of black box environment that your server was spawned into, your Jupyter server. So you're a bit more resource constrained in that than you would be on like a full cluster of bare metal machines.
Right. So I see that there's a Testbed API, which is that primarily doing allocations and things like that? Or
yeah, that's primarily for for sort of fetching information and influencing state on the testbed itself. So that's all things like making requests for resources, allocating resources, provisioning nodes, asking for floating IPs, and also there's some stuff in there that is useful for networking experiments, such as creating a network on a certain VLAN tag, because we do a lot of virtual software-defined routing internally to make all of this work for everybody.
Right.
So anything that involves configuration of the testbed is what that command line client is used for.
There's already a bunch of tickets. We're getting emails.
Perfect. Thanks, Jason. I appreciate it.
Yep. Thank you.
Bye-bye.
Yeah, so my hypothesis is that there's something up with the tutorial project for some reason. So I think I'm just going to need to look into that slightly.
Asher, you're free to talk and ask your question.
Yes. Hi, Jason. Is Jason still there?
Yep, still here.
Yes. So mine is like a different question. I'm just thinking if that services is possible on the Chameleon project, where maybe I can set up a test bed with some couple of maybe switches and routers where I can listen to the traffic and collect data. So I've been going through the SDN the SDN. I think there's a blog on SDN.
Mm-hmm.
So yeah, that's my question. I'm just trying to find out if that service that sort of service exists on Chameleon, where I can set up my own test bed from scratch, including maybe some couple of routers and switches where I can maybe generate traffic and just a normal test bed, basically.
Mm-hmm. Paul, maybe you're a better person to answer that than myself. Are you still on?
Yeah, I'm still here. So yeah, that's all possible. So we have what we have is in each of the sites we have OpenFlow switches, and they're special OpenFlow switches. They're maybe a company called Corsa, and what they have is sort of ingrained in the way they work is you partition up the switch into sets of ports, and each one of those sets of ports gets its own OpenFlow controller.
Okay.
So what we can do is we can actually give you your own OpenFlow switch, which you can then turn into a router or whatever you want it to be using OpenFlow, using whatever OpenFlow controller you want, and you can put that OpenFlow controller wherever you want. And we have a few sort of canned ones that'll do some basic stuff, but if you want something complicated, you can do whatever you want. We also have the ability to take layer 2 circuits and extend them outside of the site to anywhere that can be connected to AL2S, which is Internet 2. And so we connect to Genie.
Okay.
So we have we can connect your experiments on Genie to your experiments in Chameleon. We could also use that to connect your experiments that are on University of Chicago part of Chameleon to the Texas Advanced Computing Center part of Chameleon. They can connect those with layer 2 circuits that are pretty high bandwidth, up to 100 gigs even.
Okay, sounds good.
And you could do so you can deploy like what you might want to do is I didn't hear the very first part of what you were saying, but we can deploy OpenStack.
Okay, yeah.
Into a set of nodes that we have deployed for you, even though we're deploying them with OpenStack. So you can kind of put OpenStack inside of OpenStack.
Okay.
It's a little tricky. So does any of that stuff kind of what you're thinking, or?
Yeah, something like that. Yeah. Yeah. So yeah, sounds good. I think I've got your email. So I'll keep in touch. I'll drop you an email on. I'll just give you a brief of what.
Yeah, if you look in the complex appliance section of the main webpage, there's a few. There's one that's called like OpenFlow Getting Started Appliance or something like this. You might look at that one.
Okay, is it on the documentation page you said?
Yeah. There's definitely in the documentation. There's definitely stuff about OpenFlow and software-defined networks.
Okay.
There's some complex appliances that you can just sort of turn on. There's a very interesting one that uses it's called Security Onion appliance that'll actually run Bro and do some monitoring using OpenFlow to monitor the switch. That's an interesting one.
Yeah, that's an interesting one. Yeah, sounds.
So we can get you started using any or all of those.
All right. Okay. Yeah, that one sounds more a bit similar to what I'm trying to do, which is listening to and monitoring.
Mm-hmm. And we have like our own work that we do. We have much more complicated ones than those. We don't necessarily publish all of them.
Yeah.
If something specific you want to do, we can probably make it happen.
All right. Okay. Sounds good.
Yeah.
So I'll have a look at the documentation page and have a read. Then I'll also drop you an email if I've got any.
Yep. Sounds good.
Yeah. Thank you very much.
Thank you.
All right, Richard, do you still have a question?
He's muted here.
He must have it.
Yeah. Shadea, do you have a
Can
question?
you hear me? Sorry.
Oh,
there we
now
go.
we got Richard. Okay.
I have the same issue. I guess we'll just have to wait and see the issue with not being able to launch the server.
Mm-hmm.
Yeah, so I guess I can just wait and see and try to log in at a different time, see if it works.
If you create a ticket, then we'll we can look at your account specifically and see what's happening. But probably they're all the same problem, and Jason can just fix it and answer them all at once.
Yeah,
Okay.
I think I did find that I think actually this part of the confusion stems from there's a bug in the login where if for certain things it'll actually sort of imply that you're able to log in, but actually there was a problem doing so, which is how you get into this state. So I think there is something going on with maybe the tutorial project or some of the way that users are attached to projects, but I do suspect there's like one bug that is affecting everybody that we should be able to fix up shortly.
Okay. Yep. Sounds good.
All right, Shade, do you have a question?
Yeah, maybe. Can only do so much.
All right. Well, I think that's everyone. As they mentioned, if you do have any more questions, feel free to submit a ticket. They'll get back to you. And again, we really appreciate everyone's time and have a great rest of your day.